That's working better. That's super free.
Okay.
So all that did help.
Yeah.
This is our worst one right here. Ooh, a little heavy. Oh, pretty good. See, it's starting to get a little gap all the way around now.
Mm-hmm.
This one has a big gap right here, see, but not much here. This one still needs to go this way, and that one looks pretty good. So which ones are we going which way? They both need to go that way right here.
Nice. Okay.
When you get to the dowels is where it gets tight. So. Boom. Oh. So we're good there. See how far we're going on now? Right to there. That last push on is where it goes on. So we got improved pretty good. See, this one does that last little bit before it gets tight.
Right on this dowels.
But it comes off relatively easily.
Yeah.
I don't know why it comes on. It goes on an angle like that. But that's just where it wants to be. Now, when you tighten all these down, the pressure will, like on this stud where it moves pretty easy, will actually pull it straight and hold it there.
Mm-hmm.
We haven't done any of that kind of. We haven't tightened anything yet. So that would help it a little bit probably also. But for now, it's pretty good. It's off pretty easy. The gears all fit in there now. So it goes on there pretty good. So it's close enough. It was close enough before, but it works a lot easier now.
Well, at least this is not binding up now too.
Right, another half hour of wasted time, but yeah, it goes easier now. This one makes a difference to the mechanic because it looks nice for me when it comes out. But the less stuff you have binding, the better.
Yeah.
So we have no more, there's no binding on this. The gears are now spinning pretty freely. So I think everything looks pretty good on that. I don't know what gasket we're going to be using on this side. So we have our 2 gears here. It's basically like flush.
That's good.
No, that means there's no room for a gasket. The gasket is going to be clearance. So.
Oh, right.
So yeah, this one could use a 2 thou gasket. So we're definitely going to have to use the 5 thou. The thinnest gasket we got here we got to use. And over here we're probably good with a 9 or 10. So, but the pressure side, it's basically it's flush. See, it doesn't really catch the gears at all when you come across like this. So whatever the gasket is, that's our clearance. And 5 thou clearance is a lot of clearance.
I thought we were going to do some type of coating. There's some coating you were talking about?
Yeah, I don't think we're going to do any coating. These are already pretty tight now because we had to come, we had to find out small ones already. I don't think we need coatings. You can coat the teeth and they would wear to fit, but it's, I think in this application we're already tight. We're pretty snug already on that department. So there's where the shaft is going to be. Sits right about here. Well, they're not quite real well because this is not being held where it's going to sit yet, but you can see how these rotate pretty nicely. And even these ones are working now. Before everything was binding up a lot more. So, so I think overall we're in pretty good condition. Obviously you put the keys in, you can rotate it correctly, but yeah, that'd be too easy. Alright, so we got our pinion shaft fitted, we got the oil pump dialed in, we got all the gears, all the studs. So that part's handled. I don't like these threads, but it is what it is. We know what gaskets we need, one they don't make and the regular one. So we'll have to find the thinnest gasket we can get for that. And so all we can now is, next time we'll do the bushings here, we gotta ream this one bigger, and we gotta swap this out to the later bushing.
Right.
So we'll have to change that out. And then we gotta get the idler shaft in here, and that will make sure that all goes on and off relatively freely there. Now has this been on the motor here yet or not?
No.
So we don't even know if this fits yet.
Not bad.
Yeah.
Coloring matches nicely with the motor too.
Yeah. See, this here actually engages inside this hole. So the dowels are pretty loosely cut, I bet. Yeah, see how loose they are?
Yeah.
This is a lot tighter, so this is the hole here where it's going binding slightly.
Yeah, you can see a little.
See it's sitting on the bottom? So if you do a little friendly persuasion. Oh, is that the way you want to go? No.
The other way, yeah.
Twice.
Yeah. The makeup and then the correction. They're perfect.
There you go.
Nice.
Nice loose, see? Friendly persuasion. Hammers work good. But you have to know how to use them. Don't hit them the wrong way.
Right.
Okay, so now we don't have to fight that. That's nice. The problem is the dowel pins are loose. It shouldn't. See how much that moves? That's how much all this moves here too. When we're trying to do our fitting.
Wow. Yeah.
But also, what you don't really is the gears in here are moving also.
Right.
That changes your backlash, your noises you get.
But there's nothing really you can do about that.
No, aftermarket makes their bushing holes really, their dowel holes real loose so that they will go on.
Yeah, they fit applications.
Yeah, so there you go. So when you got an extra 5 thou clearance, yeah, that's got a lot of clearance in there. That's 10 thou.
Yeah.
You can't have precision if you make your precision parts loose as a goose.
Yeah, exactly.
That's the problem with everything aftermarket. They make it really loose so that it will fit on most every application out there. So it basically sucks. But it makes it easy to put on.
Is there anything we can do to tighten that up?
Not really.
These won't help lock it in too?
Yeah, but they're all fighting each other too because screws are not concentrically made.
Right.
You know, the dowels are supposed to align the stuff. So no, there's nothing you can really do about it. And after you put everything on there and tighten it down, you don't know what you got to do to make things free up.
Right.
And it's going to change
You
every
can't
time it
see
goes
anything.
down because it can go here, there.
Yeah, exactly. Yeah, you have 10,000.
You know, all these screws here are going to affect how it holds together, and every screw is different. As you rotate the screw, it changes the angle it wants to push, and they're all fighting each other. It's going to wind up wherever it wants to be.
Right.
It has an orbital direction it can be in any of those positions.
Right.
And the problem is that changes your bushings over here in your cam. They're moving all around also. That's why everything has to be semi-loose so it will work.
Right.
If you get it too tight, the alignment has to be perfect if it's too tight.
Yeah, exactly. Which you won't get that perfect alignment with this fit.
See, that's the problem I have with my stuff. I try to make the holes too precision, too tight, and then it causes problems because there's no air, there's no built-in misalignments.
Right.
And a little bit of misalignment, like the studs were binding up on this, it makes the pumper won't go on. It made the shaft bind up until we got it squared away. The same thing, misalignments
Right.
are a problem if the tolerances are too tight.
Yeah,
Now,
exactly.
if that hole was all eaten out, that would have worked fine no matter
Yeah.
what it was.
Mm-hmm.
And most people just make the hole super loose, so anything can work.
Right.
Me, I don't like that because I don't like having
That chatter.
alignments like this.
Mhm.
That sucks. So, but hopefully with all the parts together, it will go down in a position it likes.
Mm-hmm.
It doesn't bind.
Right.
Yeah, but if it does bind, there's not much you can do about it. It's just going to have to wear in. That's why your shaft here was worn real heavy here. It was binding.
Mm-hmm.
Probably because the crank was bent, but
Right.
maybe the cam cover and bushing hole didn't match.
Yeah. Was after my cam cover previously
Yeah,
as well.
So you don't know. It just all you know is it wasn't happy because it's got a wear mark there.
Mm-hmm.
So, but anyway, this now goes on. But I know that's going to all your aftermarket stuff is made the same way.
Mm-hmm.
And chances are this hole is very loose inside of there too.
Yeah. Can we test that? That way?
It might just get in there. Yeah.
Yeah.
Same clearance. Yeah, it was so far off with binding originally.
Mhm.
Just gonna beat it over, it cleared it. And that's why the rub mark is only so thin. If it was closer in size, it would be rubbing on a larger area.
Yeah.
So, well, like I said, it is. You got what you got. You didn't like that ugly ass chrome cover you had originally.
No.
So.
Well, it had a weird welded section in that oil gallery too. This here was probably 2/3.
Oh, it was all welded in there?
Yeah.
Okay. Yeah, you took it out, can you put it back? There you go. Yeah, your case has been repaired a lot, so. See how repair all went away, pretty much
Mhm.
disappeared. You can still see the pinholes from the corrosion. Yeah. When you weld aluminum, you always have an outer layers. Crap.
Right.
Excuse me. Nice. So the, you got the scale on aluminum basically. The outer layer is kind of corroded from the
Right.
atmosphere, which keeps it from corroding heavily.
And
But when you try to weld it,
so it's pushing all that
that
out.
contaminates the weld and you get these little holes.
Mm-hmm.
So it's hard to get a clean weld all the way across, especially on really old aluminum because there's a heavy layer of buildup.
Right.
I've actually welded cases where the buildup will melt. I would melt the aluminum away from the buildup, and you have the scale sticking up there, about 20, 30 thou above the weld.
Wow.
And you just touch it and it flakes off because it's scale. It's like crystal,
Mm-hmm.
But you can't weld to it. It will not.
Right.
It won't weld to it.
Mm-hmm.
So it just kind of. You keep going across, it just follows it across because when you
Right.
melt the aluminum, you can weld to that. That's fine, but the scale is scale. The scale drops into your weld and you blow it out, but
Right.
it's still, you can't get a nice clean butt weld to it.
Mm-hmm.
So you always have an area where you can't see it. But like some parts over here clean up real nice, and other parts it's pretty scaly.
Mm-hmm.
If you go back over and weld it 2 or 3 times, it might get a little bit better, or it might uncover some more crap.
Right. But it's really not that bad.
But, yeah. No, it looks pretty close. And yeah, the blasting is pretty clean, so it does look good. There's oil over here or something from where I assembled it. So you'll have a nice, pretty evenly looking motor.
Mhm.
Now the lifter blocks are going to be silver or black.
Yeah, they're silver. Those SNS ones, we were going to blast them.
Oh, those are aluminum ones.
Yeah.
Okay, what about the pump? You make it aluminum or black?
I probably CAD aluminum paint.
Silver. Yeah.
Mm-hmm.
You can use silver paint, which is bright, or you can use dull aluminum.
Oh yeah, we'll
Which
do
is-
the dull.
It's more like this.
Mm-hmm.
So if you're trying to keep it well toned down real heavy, you do the dull aluminum. With the polished lifter blocks that they are now and it's smooth, if they're probably still going to be pretty smooth looking. If so, then maybe you make that make this silver instead of dull.
Yeah.
So that way
Tie into
parts
those,
kind
yeah.
of look together.
Mm-hmm.
I don't like it when everything in the motor is one color.
No.
So you get all CAD hardware, all blasted stuff here, and the factory silver paint on your blocks and stuff like that
Right.
on the steel. And all you look at, you see a gray
Yeah.
with little
Exactly.
different tones to it.
Yeah,
No,
there's
there's
no-
no
yeah.
contrasting to it.
Mm-hmm.
So the black lifter blocks and oil pump actually make it look a little better.
Yeah, that makes
And even
sense.
maybe the black screws. oil
Yeah,
pump
and then the
screws.
black cylinders as well.
Yeah. All right, that's it for tonight.